Yes, a very good afternoon. Audible, visible, everything is okay, perfect there? Okay, good. Hopefully all of you are doing good. Yes. Okay, how far we have done in the last class? I think I might have finished off with the enthalpy of combustion and all the numericals associated, if I'm not wrong. It's absolutely fine, beta. And if somebody is counting, this is last class before holidays. And already you people have come into that holiday mode. Do not activate that mode, still test is there. After that you can. Combustion is completed. Okay, fine. So let us go for the next one here now, which is enthalpy of neutralization. Enthalpy of neutralization. And here I'll be writing delta H neutralization. Now when it comes to neutralization, basically we refer to reaction which is happening between acid and base, right? Now for defining something, so scientists have to take some basis. So according to them, what is enthalpy of neutralization? That basically whenever one equivalent of any acid, right, reacts with one equivalent of any base, then whatever is the enthalpy change during that particular process, that is known as enthalpy of neutralization, right? And I think Madhava, you have come for the very first time here online. So when I start teaching, I do not want any unnecessary messages there. If you are having any doubt, whatever I'm teaching on the board, please do that. I'm not an admin person there to, kind of give whether the exam is there on Saturday, Sunday. I'm not the responsible person there. So those who are new to online, make sure that you understand that you have to maintain the same decorum of the class which you maintain in the offline as well. In the offline, do you ask whether during the lecture, whether exam is on Sunday and Saturday? You do not. So do not do that, the same thing here also. And I'm not the concerned person for answering this doubt. Now write down the definition here. The enthalpy change when one equivalent of acid reacts with one equivalent of base in a very dilute solution, to form salt and water. So you must be very careful that we are going for when one equivalent of acid reacts with one equivalent of base. It's absolutely fine. So the thing is, you have to maintain the decorum of the class wherever you are, whether it is online or offline. Now here we are going to see the case. Now all of you listen carefully here. Whatever it is, Madhava, now please pay attention there. So did you understand the basic definition, what they are trying to say? Neutralization means one equivalent of acid should react with one equivalent of base, and whatever is the enthalpy change during that particular process, that is only known as enthalpy of neutralization. Okay. Now the next thing is, there are two cases which we need to understand here. Maybe when you are carrying out the neutralization, both acid and base both are strong, or else it could be the case that either of them are weak, or else both could be weak. So we are first going to understand about if both acid and base are strong. If both acid and base are strong. So in this case, how do we go for it? Let us go for a very simple example like HCl aqueous plus NaOH aqueous. And here it will be forming NaCl aqueous plus H2O liquid. Now this is a reaction which is already balanced, and I am saying here Enthalpy change during this reaction is nothing but it is representing the enthalpy of neutralization of a strong acid and strong base, and we have to remember a particular value or else fixed value, standard value, which is minus 13.7 kilocalorie or else minus 57.5 kilojoule per equivalent. So do remember here how do we interpret this first of all? That when one equivalent of a strong acid reacts with one equivalent of a strong base, how much heat will be liberated? 13.7 kilocalorie. Or else when one equivalent of the acid reacts with one equivalent of a base, 57.5 kilojoule of energy will be liberated or heat will be evolved. Are we able to understand this, right? Understood? So if at all two equivalents react, so 13.7 into 2. If at all three equivalents react, then 13.7 into 3, right? Accordingly, the things will be. Now, one more thing is, HCl is a strong acid, right? If HCl is a strong acid, then it will be definitely dissociated completely in this form, H plus aqueous plus Cl minus aqueous. Same thing applies for NaOH also. Here, NaOH also will be basically dissociated as Na plus aqueous, OH minus aqueous. Now, NaCl's aqueous is basically a soluble salt. So that will be existing as what? Into its separate ions itself, Na plus aqueous plus Cl minus aqueous. But you will not be breaking down this water. It is a weak electrolyte. So you'll be writing like H2OL only. Now, can I just remove the spectator ions from here? And will I be getting the equation like this? That says H plus aqueous plus OH minus aqueous, right? It is going to form H2O liquid. So actually in neutralization, it is H plus which is reacting with OH minus to give you H2O. So now onwards, I'll be simply denoting this as delta H neutralization of a strong acid, strong base, whose value is this. So it simply implies that when one equivalent of H plus reacts with one equivalent of OH minus, then 13.7 kilocalorie of heat is liberated. Is there any doubt to anyone in this? So now onwards, whenever I am writing delta H neutralization, strong acid, strong base, it means that I am referring to this reaction where H plus plus OH minus is giving you H2O. Is there any doubt to anyone? Please write it down, then we'll proceed further. Good, please write it. Once you are done, write down done there so that we can proceed further. Okay. Now let us go for some question here. And here one more thing that you people should be knowing about the formula also. As such, you might have already studied. But still, just a quick recap. How do you calculate number of equivalents? If at all normality is given, volume in liter. Similarly, you write down normality as molarity into n factor. So I can also write down molarity into this, into n factor, or else number of moles into n factor. Even number of equivalents is weight upon equivalent weight, but we do not require this formula here, so I'm not writing. Similarly, milliequivalence is equal to normality into when you take volume in ml. Similarly, molarity into volume in ml into n factor, and then millimoles into n factor. And here we are going to deal with acid and base. So n factor for acid will be from its own molecule how many H plus ion it is able to give. That will be n factor for the acid, and n factor for the base will be how many OH minus ions it is able to give from its own molecule, right? So just be careful. You have already studied about that in redox. So I'm writing here, calculate the amount of heat evolved in the following given deltaH neutralization of strong acid, strong base is minus 13.7 kilocalorie per equivalent. Now one more word here, or else one more important thing here. Here you know that this is the standard data, which is like one equivalent when they react, 13.7 kilocalorie could be liberated. But sometimes what happens is examiner may give you some other data, right? Just to make the calculation more simpler. That means maybe deltaH neutralization of strong acid, strong base is, suppose they are giving you minus 50 kilojoule per equivalent. So for solving that particular problem, you consider the value which is given by the examiner, right? And if the examiner is not giving you any value, right, not giving you that deltaH neutralization of strong acid, strong base specifically in the question, then they are expecting that you should be knowing that value, and that value you already know, which is 13.7 kilocalorie per equivalent or is 57.5 kilojoule per equivalent. Are we able to understand that part, everyone? So if something is already provided by the examiner, please take that value. Do not think, no, something is wrong, I should not use it. Are we able to get it? Now, here I am writing down the first one, 100 ml of 0.1 molar H2SO4 aqueous. It is reacting with 100 ml of 0.2 molar NaOH aqueous solution. This first question I'll solve, next question you are going to solve, right? Try to understand this. First of all, you find out the milli equivalents of H2SO4 here. That will be molarity into volume into N factor. And why I'm writing milli equivalents? Because I know that volume is given in ml, okay? So here it is 0.1 into 100. N factor for H2SO4 will be 2, right? So are you getting here 20 milli equivalents? So number of equivalents of H2SO4, it will be 20 into 10 to the power of minus 3, which gives you 2 into 10 to the power of minus 2. Are we able to understand here? Did you understand what I've written on the board? Simply I have found out the milli equivalents here. Now for this also, milli equivalents of NaOH will be what? You have to write down molarity into volume into N factor. So basically you are having 0.2 into 100 into N factor for NaOH is 1. So will I get 20 milli equivalents here? So number of equivalents of NaOH, it is going to be again 2 into 10 to the power of minus 2. Simply you have to multiply by 10 to the power of minus 3 here. Now, according to the data, what is given here, when one equivalent of acid reacts with one equivalent of a strong base, how much heat is liberated? 13.7 kilocalorie. Now, how many equivalents are reacting? 2 into 10 to the power of minus 2. So, if these many equivalents are reacting, simply you have to multiply it by 13.7. It is just like rate of 1 chocolate is 10. So, rate of 2 chocolates will be 2 into 10. Are we able to get it? So, here I'll write down one equivalent of acid and base, when they react, how much amount of heat is liberated? 13.7 kilocalorie heat is evolved. So therefore, how many are there? So therefore, when 2 into 10 to the power of minus 2 equivalent of acid and base react, it is 13.7 into 2 into 10 to the power of minus 2, which is 27.4 into 10 to the power of minus 2 kilocalorie of heat evolved. Or else can I write down 274 calorie? This much is evolved. So you should be very careful about one thing. If they are asking you enthalpy of neutralization here, you will be reporting minus 274 calorie, because enthalpy of neutralization is always negative, right? And if at all they are asking you heat evolved, so you should be only reporting 274 calorie, only the magnitude, because evolved means already negative is under consideration. Is there any doubt to anybody? And do not think that this is a very big problem, since I've written each and every step. That's the reason it is looking little bit bigger. Otherwise, simply in the examination you find out milli equivalents or the equivalents. For one equivalent you know, for these many equivalents you multiply by 13.7. Your problem is done there itself. Are we getting it? So please note it down. Is there any confusion to anyone here? Because next problem you are supposed to do. Is there any trouble to anybody in understanding this problem? Kartike, what you are writing? No, if you wish to keep it in kilocalorie, that's okay, beta. If you have to calculate in calorie, then also it is fine. It is not mandatory. It will all depend upon how the options are given. From kilocalorie to calorie, I have simply multiplied by 1000 now. From kilocalorie to calorie, I have simply multiplied by 1000. There is no magic there. Getting it? So it's not mandatory. I have just given you, okay, from kilocalorie also you can reply and for calorie also, because it all depends upon what is the way in which options are given to you. Okay? Are we done? Okay, so now next question you are supposed to do. 100 ml of 0.1 molar HCl aqueous. It is reacting with 100 ml of 0.1 molar KOH aqueous. Tell me how much heat evolved. Giving you next problem, all of you try it. I think Raymond has calculated and Vishesh has calculated, Reshma also. Yes, many of you, good, very good. Jonathan also. So the thing is, simply find out the milli equivalents of HCl, that is here 10. So number of equivalents of HCl is 10 to the power of minus 2. Here also milli equivalents of KOH is 10. So number of equivalents of KOH will be simply 10 to the power of minus 2. And I know for one equivalent, how much is liberated here? 13.7 kilocalorie is evolved. Right. So one equivalent acid and base react for that way. And if at all, therefore, for 10 to the power of minus 2 equivalent of them reacting, it will be 13.7 into 10 to the power of minus 2 kilocalorie. Or else 137 calorie, this is evolved. And if at all somebody asks you what is the enthalpy of neutralization, minus 137 should be answer. Yes, I think majority of you have solved it. Wonderful, na? Preeti and many more people here. Okay, next question I am giving you. 100 ml 0.2 molar HBr aqueous. Plus you are having 100 ml 0.1 molar KOH aqueous. Now here are the milli equivalents same? Are the milli equivalents same here? No. So in that case, whose ever milli equivalents are less, that will become the limiting reagent, because neutralization will happen till the time both acid and base are there, na? Right? If one of the component is over, then there is no neutralization here. So you have to find out according to the number of equivalents of the limiting reagent there, right? So here I'll be simply writing down milli equivalents of HBr is 20 and number of equivalents of HBr is going to be 2 into 10 to the power of minus 2. Similarly here, milli equivalents of KOH is 10 and the number of equivalents of KOH is going to be 10 to the power of minus 2. So this becomes your LR. So simply I'll be writing one equivalent of acid and base reacting. For that one, it is 13.7 kilocalorie of heat which is evolved here. So therefore, for 10 to the power of minus 2 equivalents of them reacting, And this we are writing according to LR. This is according to LR. So I'll be getting 13.7 into 10 to the power of minus 2 kilocalorie, which is 137 calorie of heat evolved. Are we able to get this, everyone? Yes, majority of you have got it. Wonderful. Fourth one I am giving you. 100 ml 0.1 molar H2SO4 aqueous, and you are having 400 ml 0.1 molar KOH aqueous solution. Those who have finished, they can solve this out. Manas, I think Lakshmi. Good. Kaushik also correct. Reshma, check your answer, beta. Did you multiply by 2 or not? Reshma, check your answer. Adarsh also correct. See here, simply you have to see milli equivalents here. Milli equivalents of H2SO4 is actually 100 into 0.1 into 2. N factor is 2 here. And here, milli equivalents of KOH is how much? 40. So number of equivalents of KOH is going to be 4 into 10 to the power of minus 2. And here, number of equivalents of H2SO4 is going to be 2 into 10 to the power of minus 2. This time, this is becoming your LR. So it is simple only. So I am writing here, for one equivalent, how much is getting liberated? 13.7 kilocalorie. So therefore, if at all it is 2 into 10 to the power of minus 2 equivalent reacting. So in that case, it will be 13.7 into 2 into 10 to the power of minus 2, which is 27.4 into 10 to the power of minus 2 kilocalories, or else 274 calorie. This is also evolved, and here also it is evolved. So I hope this is clear to everyone what we have done on the board. Yes, I think majority of you have done it correctly. Very good, right? Now let us go for the next question now. Calculate the amount of heat evolved when 0.2 moles of HBr reacts with 0.6 mole of NaOH given deltaH neutralization for a strong acid, strong base is minus 20 kilocalorie per mole. Now here purpose of giving this problem is, yes, I think those who have responded, they've responded it correctly. Now majority of the time examiner will give you kilojoule per equivalent, but they may also give you data in the form of, kind of per mole also, or is kilocalorie per mole, kilojoule per mole. So how you should take it? It is simply telling you if 1 mole of strong acid is there, it is reacting with 1 mole of strong base to basically give you what? Salt and water. At that time, whatever is heat evolved, it is basically here 20 kilocalorie, right? And I think Vishesha has basically given the answer also. Good. So simply what you should be writing here, you should be writing HCl plus NaOH giving you what? NaCl plus water. Now the thing is, number of moles here is 0.2, here it is 0.6. So how do we find out basic the limiting reagent? Do you remember? Number of moles upon the stoichiometric coefficient, right? So this is 0.2 upon 1, 0.6 upon 1. This is your LR. So that way you should find out which one is your LR. Do not think that whosoever number of moles are less. Here the stoichiometry is 1. If the stoichiometry is not 1, then it will be trouble. So here I can simply write down for 1 mole of acid and base reacting, you are having 20 kilocalorie of heat evolved. So therefore, for 0.3 moles of acid and base, 20 into, in fact, I have given you 0.2, not 0.3. So 20 into 0.2, you'll be having 4 kilocalorie. This much is evolved. Are we able to understand? Acha, I have written HCl or HBr, bhai? Have I given you HBr? Acha, theek hai. Same family here. Let us, kind of simply replace it here. HBr here and NaBr is here, right? Yes, done that, not an issue. HCl and HBr, not an issue. Ultimately, concept remains the same, right? Hopefully it is clear to everyone. Now let us go further to the next case here. Case 2. If either acid or base is weak. So for strong acid, strong base case, it is very clear that if at all, you simply have to see that whether it is like, one equivalent is reacting with one equivalent, or else how many equivalents are reacting with each other. If same number of equivalents you are getting, to simply have to multiply by those number of equivalents into 13.7 or else by 57.5. But if you are getting unequal number of equivalents, then whosever milli-equivalents are less, that becomes your limiting reagent, and based on limiting reagent, you have to find out how much heat will be evolved. That much you keep in mind, that's absolutely fine. Now let us go for the case that if at all either of them is weak, right? For example, if at all I am writing something like this, CH3COH aqueous plus NaOH aqueous, this will be giving you CH3CONa aqueous plus it will be forming H2O liquid. Now this reaction is balanced, and whatever is the enthalpy change during this reaction, it is actually neutralization of a weak acid by strong base. Now do you think that 13.7 kilocalorie only will be liberated in this case, or else it could be lesser or more than that? What is your thought in that? Whether it is 13.7 kilocalorie which is going to be getting liberated, or else lesser than that, more than that. Write your opinions on the chat box there. Somebody is writing less or more, hai na? I should choose between less or more. I gave you one option. So for weak here, basically it is less. Reason being, some amount of that heat which is about to get liberated, that is 13.7 kilocalorie, some amount of that will be utilized for dissociating of this weak acid or weak base. Okay, good. Now the thing is, I have written this reaction in one step, and you know that every time Hess law is always valid, right? Hess law means I can break down this reaction into 2 to 3 steps. Let us say when we are breaking it down. So when I am having CH3COH aqueous, I can write down this as CH3CO minus aqueous plus H plus aqueous. Now for dissociating it, I need to provide some amount of energy here. So I can write down delta dissociation or ionization. It will be non-zero. Non-zero value means some value will be there. Some positive value will be existing. Similarly, if at all I am having NaOH aqueous, this is already a strong electrolyte. It will already be dissociated 100%. So in this case, I'll be saying that I am not supplying any energy for breaking it down. So delta H dissociation is less, or else in fact it is zero. I'm not saying less, but it is zero because you are not supplying any energy. It is already broken, right? Now the moment you are having H plus and OH minus in the system, can I write down H plus aqueous plus OH minus aqueous? Will you be writing this as H2O liquid? And what this reaction is telling you, is it enthalpy of neutralization of a strong acid, strong base? Do you remember we have written that reaction only? And if I combine, add all these three reactions, this H plus goes away here, OH minus goes away here. So ultimately, am I getting the required equation, which is CH3COH plus NaOH, which is giving you CH3CONa plus H2O, right? And delta H for this reaction will be obtained from the summation of all these three, right? So ultimately I'll be writing here delta H reaction that is equal to delta H. What is this delta H reaction? Is it telling you that it is delta H neutralization of the weak acid and strong base here? So I'm writing delta H reaction, or else here in this case it is delta H neutralization of a weak acid by strong base. That will be equal to delta H neutralization of strong acid strong base plus delta H dissociation of the weak acid. I am simply adding up these three. Second one I am not adding because delta H dissociation is 0, right? So this is an important formula which you have derived here. You simply have to remember the formula here. Now one more thing of word of caution here, this delta H neutralization for the strong acid strong base, this should be according to number of equivalents reacted. So according to number of equivalents of H plus and OH minus reacting. Now what is the meaning here? Let me tell you. In this case, what I have taken CH3COH, right? CH3COH will be able to give you how many H plus ion from its molecule? How many H plus ion it is able to give you from its own molecule? CH3COH, if at all I supply energy, break it down, how many H plus ion it will give me? 1. So the thing is 1 H plus minus reacting with 1 OH minus giving you H2O. So that's the reason when I am substituting the value here, I should be writing minus 13.7 kilocalorie. Now imagine that rather than basically acetic acid, I have given you H2A, which is a weak dibasic acid. Dibasic acid means what? It will be giving you 2H plus. So at that time what I should be writing? 2H plus 2H minus giving you 2H2O. So the delta H neutralization here should be minus 13.7 into 2. Are you getting it? That is the meaning of according to the number of equivalents of H plus and OH minus reacting. Write this down quickly. And see here I have derived the formula only for weak acid strong base. Need not worry about the derivation, that is only for your understanding purpose. Only thing is you should remember this formula. Similarly I can also do the variation here for the formula. That means delta H neutralization for weak base strong acid. This will be equal to again delta H neutralization of strong acid strong base plus delta H dissociation of the weak base here. These two formulas are very important, you have to remember. Similarly, if both of them are weak, delta H neutralization, you are having weak acid, weak base, then it will be delta H neutralization for strong acid, strong base plus delta H dissociation for the weak acid plus delta H dissociation for the weak base. Please write it down, then we'll proceed further. Is there any trouble understanding for anyone? Write it, then we'll proceed further. Yes, I will. Do not worry. Yes, I have scrolled it. Harshvardhan, strong acid and strong base, they will always be 100% dissociated. You need not supply any energy for dissociating that bitter. That's the reason delta H dissociation will be 0 there. Along with sign only you have to keep. Yes, Raymond, you have to keep along with the sign. In fact, data will also be written like that. Okay. Yes, I am scrolling it up here. Please write down. Can't see last part. Yes, last part I have just now shown it here. Quickly finish writing it. See, the thing is, this formula we have written for the sake of writing it, right? And these two formulas you must remember very nicely, okay? And whenever I am saying that delta H neutralization, strong acid, strong base, do not think that you are, neutralizing them. I am just referring to H plus and OH minus reaction giving you H2O, which is nothing but delta H like that. No, Harshvardhan, see, whatever is your doubt, right? So please, you ask your doubt. Need not be sorry there. For any student, your doubt could be silly, not an issue. It is most welcome, right? I'll answer that. But I'm having trouble if at all you ask unnecessary, here and there, extra management question and all those stuff, which I'm not answerable for. So never be sorry and never think that, your doubts are silly, because many of you, sometimes it happens, others are also having the doubt, but they do not have the courage to ask it. So please ask it, not an issue. Okay. Reshma, which thing you are applying, yaar? I do not know. Which mathematics and which chemistry? God knows, na? Do not apply mathematics here in chemistry here. Let me tell you why I am saying though. I'll write down here delta H neutralization for a weak acid strong base or weak base strong acid. It is lesser than delta H neutralization for a strong acid strong base. And when I'm saying that, here if at all I write down minus 13.7 kilocalorie, na? So let us say, for example, here it will be lesser than that, minus 10 suppose, chalo, for example. Okay? So if I'm taking only minus 10, mathematically minus 10 is more only as compared to minus 13.7. But I am asking you enthalpy of neutralization means where more heat is evolved. More heat is evolved in case of strong acid, strong base. I hope, Reshma, I answered your query there. Okay? So let us go for the question now. Given delta H neutralization of HCl by NaOH is minus 55 kilojoule per equivalent, and delta H neutralization of HCl by NH4OH is minus 40 kilojoule per equivalent. Find delta H dissociation of NH4OH. Please find it out, everyone. See here, I have written in this format in the examination in the form of word statement. It will come that when HCl is neutralized by NaOH, 55 kilojoule per equivalent amount of heat is released, or like that. So they may write down in the form of statement. Try to find the value here. What the examiner has given you. This data is telling you strong acid, strong base neutralization. This is telling you strong acid, weak base neutralization. Yes, majority of you have got it. Very good, 15, right? So the thing is, you should understand one thing. If at all I have given you a weak base, that weak base is able to give you how many OH minus from its own molecule? Only one, right? So I'm writing here something like this, NH4OH, which is giving you NH4 plus plus OH minus. And this H plus and OH minus, they are reacting to form H2OL. And in fact, here delta H neutralization will be what? Minus 55 kilojoule only, because one equivalent. Here, one equivalent of H plus is reacting with one equivalent of OH minus. So simply I have to use the formula delta H neutralization of a weak base by strong acid, that is equal to delta H neutralization of a strong acid by strong base plus delta H dissociation of this weak base. So here I have given you minus 40, this is minus 55, and I am writing X in its place. So ultimately X will be equal to plus 15 kilojoule. That's your answer. Is there any doubt to anybody? Kartikeya, you are asking as if you do not know what is a strong acid and strong base, beta. Yeah? Strong acid and strong base, don't we know? Group 1, hydroxide you take, leave LiOH there, except LiOH, all are strong. Group 2 you go, first 2 you leave, all of them they are strong. And coming from a long-term student, it is a little bit surprising. Given deltaH neutralization for a strong acid, strong base is minus 55 kilojoule per equivalent, and deltaH neutralization of H2C2O4 by NaOH is minus 105 kilojoule per equivalent. Find deltaH dissociation or ionization of H2C2O4. H2C2O4, all the organic acids, they'll be weak only, right? So H2C2O4 is oxalic acid, and this oxalic acid is a weak dibasic acid. Weak dibasic acid. Please find out the answer here, everyone. Strong acid, all like HCl, H2SO4, HBr, HI, HClO4, HNO3. Jonathan, you have done a little bit, kind of hurry-burry with check out your answer. No, Reshma, check it out carefully. I think Raymond has given me correct answer. Good. Manas is also correct answer. Shyam also. Ganesh also. Himashu, check your answer, beta. Vishesh also. Good. Now the thing is, you should be knowing that this is a weak dibasic acid. That means if it gets dissociated, it will be giving you 2H plus C2O4, 2 minus, and this 2H plus 2OH minus, it is going to form 2H2O. So here deltaH neutralization of strong acid, strong base, that will become basically minus 55 into 2, which is minus 110 kilojoule. You should understand here you are having 2 moles of it. 2 moles of H plus, number of moles is 2, N factor of H plus is 1, so number of equivalents is 2 here. 2 equivalents of H plus reacting with 2 equivalent of OH minus. So you are having here 55 kilojoules for 1 equivalent reacting. So for 2 you have to multiply by like 55 into 2. Then afterwards simply put in the formula. deltaH neutralization, weak acid, strong base, that is equal to deltaH neutralization of a strong acid, strong base plus deltaH dissociation of your weak acid. So here I am having minus 105, this is minus 110 plus this X. X is for deltaH dissociation. So X will become equal to plus 5 kilojoule. That's what I said, be careful with this part. Whether a weak base is giving you more than 1 H plus, or else like weak base is giving you more than 1 OH minus, or else weak acid is giving you more than 1 H plus. I hope it is clear to everyone. Yes, now let us move further with lattice enthalpy here. Now when it comes to lattice enthalpy, suppose I am writing here 1 mole of an ionic solid, and I am writing here Na plus gaseous plus Cl minus gaseous. So basically what is it telling you? That whatever is the enthalpy change, during what process, when you take 1 mole of ionic compound and you are trying to convert it into its constituent gaseous ions, right? So that is what is lattice enthalpy. So I can also write down, suppose CaBr2 is there. Here I can write down Ca2 plus gaseous plus twice of Br minus gaseous. So the thing is here, whatever is the deltaH for the reaction, that is representing the deltaH lattice enthalpy for NaCl solid. Here also deltaH of the reaction is representing the lattice enthalpy of CaBr2 solid. This is CaBr2 solid. So I'll write down the definition here. And one more thing you should know, that the thing is, if I say the amount of energy required to break 1 mole of ionic compound into its constituent gaseous ions, that is known as lattice energy or the enthalpy. Similar way, one more way it is defined, that for the formation of 1 mole of NaCl solid, from its constituent gaseous ions, the amount of energy liberated is also known as lattice enthalpy, right? So normally for breaking of the lattice, like breaking of the lattice, we use this terminology more, but both the ways it could be defined. No harm is there. You should be able to get that correct, right? So here I'll be writing the enthalpy change, when 1 mole of ionic compound, is converted into its constituent gaseous ions. Fine, Amrita. In fact, those people who are there in the group already, they can share that QR code. That's itself. That will solve the query. Why we need to go to the admin and all those stuff. You people can share among yourself. Hopefully it is written. Then next one is hydration enthalpy. If somebody is not able to write down, not an issue, it will be shared in the group. deltaH hydration, or else simply only hydration enthalpy also would be written. Now we define it separately for ions and for the compounds. For ions, suppose I am taking 1 mole of the isolated gaseous ion, and what I am doing is, hydration means water is there, H2O liquid in excess, and what we are forming is A plus aqueous. Similarly, 1 mole of B minus gaseous, H2O liquid excess, then you will be having B minus aqueous. So if I want to form the definition part here, okay, Kavita, will look into it. Do not worry about it. Do not worry about that part. We'll sort it out. Okay, now you pay attention here. Now I am saying, if at all I take 1 mole of any isolated gaseous ion, and if I dissolve that in excess of water, so that aqueous ions could be formed, so enthalpy change during that process is known as hydration enthalpy. So I'll write down here, and I've written general ions here, so I can replace H plus, Na plus, or else Cl minus here. Are you able to understand? Okay, so I'll write down here the enthalpy change when 1 mole of isolated gaseous ion is dissolved in excess of water to form aqueous ions. Write this out and then we'll proceed further. Now for compounds, how do we define it for compounds? Hydration enthalpy only we are defining. And for ions, you must understand what is happening actually. You are having suppose B minus here. So B minus means water is surrounding it. That's what is hydration here. Delta plus part. Similarly, A plus around also, you will be having water surrounding this. A plus, you will be having like this, delta minus. Right? So that's what is actually happening. Now for compounds, I am writing down an equation. Based on that, you can try to kind of form this statement here. 5H2OL. It is forming CuSO4 dot 5H2O solid. Similarly, you are having CuSO4 dot 3H2O solid plus 2H2OL. That will be giving you CuSO4 dot 5H2O solid. Now here, before writing down the definition, right, you try to understand, have I taken 1 mole of anhydrous solid or else 1 mole of partially hydrated that compound? Either anhydrous compound, how many? 1 mole, or else 1 mole of partially hydrated, because if it gets completely hydrated, this is the way it exists, okay? Now, when I take 1 mole of either anhydrous or else partially hydrated compound, are they combining with certain number of water molecules? When they are combining with certain number of molecules, are they forming a specific formula, hydrate here? So during this process, whatever is the enthalpy change, it is enthalpy of hydration for this particular compound. So I'll be able to write down here delta H for this reaction is equal to enthalpy of hydration of CuSO4 solid here. And here delta H of the reaction is enthalpy or is delta H for the hydration of CuSO4 dot 3H2O solid. So I'll write down the definition part here. The enthalpy change when 1 mole of anhydrous or partially hydrated compound combines with required number of water molecules to form a specific hydrate, at a particular temperature and pressure. Now the thing is, this water molecules are just getting trapped into the crystal lattice of the CuSO4 solid, right? So the thing is, you should always remember it is solid only here, right? And when water is entering there, more force of attraction is increasing, and because of that, more energy will be liberated there, right? Similarly, when water molecules are surrounding any ion also, then also energy will be liberated because attraction has increased there. So I'll write down here a note that delta H hydration is always negative, whether for ion or else I'm talking about a compound. It is always negative. Write this down, then we'll proceed further. Finished writing? Now let us go for enthalpy of solution here. here enthalpy of solution. So how do you make a solution? Basically, you are having solute, in that you keep on adding the solvent, right? So when you basically start adding the solvent, so there could be some amount of heat changes or else enthalpy changes which you will be able to observe. You keep on, kind of adding water here or else any other solvent. So the thing is, enthalpy change will keep on happening, but there will be a time when you might have added sufficient amount of the solvent where now no more enthalpy changes are happening. So at that time, whatever is whatever is that constant value which you are recording, that is only known as enthalpy of solution. So in simple words, I can say that if I take 1 mole of the solute, try to dissolve it in excess of solvent to make a solution. So whatever is the enthalpy change, that is only enthalpy of solution. So I'll write down here the change in enthalpy, when 1 mole of solute is dissolved in excess of solvent to form solution. Now here I am writing for ions. So suppose Cl minus gas is there. Suppose I am taking H2O liquid as the solvent here. So I will be writing Cl minus aqueous. Similarly, Na plus gaseous. Here it will become Na plus aqueous. Now are you able to see that this reaction is resembling what you have written for the hydration? So for ions, I can easily say that the deltaH hydration itself is deltaH of the solution. This is valid only for ions. Write this down, then we'll proceed further. Second one is for ionic compounds. So for ionic compound, suppose I am taking CuSO4. In fact, let me write down this side a little bit. Suppose I am taking CuSO4 solid, and if at all I have taken H2O liquid excess, right? So it will be forming CuSO4 aqueous, and normally when it gets dissolved, it will be existing like this: Cu2 plus aqueous plus SO4 2 minus aqueous. Now whatever is the deltaH of this reaction, it is actually enthalpy of solution of CuSO4 solid. Enthalpy of solution of CuSO4 solid. Now I have written this in one step. It could be also written in more than one step. If I write something like this, Cu2 plus gaseous plus SO4 2 minus gaseous. So which enthalpy is represented here? You have taken 1 mole of it and you are breaking down into constituent gaseous ions. So which enthalpy I am referring to? Which enthalpy I am referring to here? In today's class only we have studied. If I take 1 mole of an ionic compound, try to convert it into its constituent gaseous ions. It is lattice enthalpy. Good. Now the thing is, from gaseous ion it is becoming aqueous ion. Is it referring to the hydration enthalpy? So can I say that the deltaH of this solution will be equal to lattice enthalpy plus hydration enthalpy? Very good. So the thing is, here I'll be writing enthalpy of solution, that is equal to lattice enthalpy plus you are having here hydration enthalpy. And direct question could also be asked here. Very simple question. That means they may give you enthalpy of solution. They may give you basically, hydration enthalpy. They may ask you lattice enthalpy. Simply put in the data, get the answer kind of thing. Write this down, everyone. And here, when I ask you this enthalpy of solution, will it be positive or negative, or it could be both? Delta H of solution, will it be always positive, always negative, or else it could be like, either. It depends on something. What does it depend upon? See, here we know hydration enthalpy is going to be always negative. Lattice enthalpy is going to be positive, right? Now the thing is, out of these two, which factor dominates? Accordingly, that will decide the enthalpy of solution. If hydration enthalpy dominates, it will become negative. If at all lattice enthalpy dominates, it will become positive, right? So it could be both. Now for covalent compound, you do not have any lattice. I'll simply write down example here. Suppose I take 1 mole of any covalent compound and I try to dissolve in excess of water, which I've taken as the solvent here. So simply it will be C6H12O6 aqueous. Similarly, it could be like this covalent compound could be present in solid, liquid, any form. Only thing is it will become here aqueous, CH3OH aqueous. Are you able to understand? Then quickly we'll see one more question here. Simply for covalent compound, there is no concept of lattice here. Lattice means it is only existing for the ionic compound. Write this down, then we'll proceed for one last question here before we wind up. So I'm writing down a question here. Given enthalpy of solution of CuSO4 solid is 25 kilojoule per mole and the enthalpy of solution for CuSO4.5H2O solid is 28 kilojoule per mole. Find enthalpy of hydration of CuSO4 solid. Try to find it out, everyone. Try to find out answer for this. All the definitions are given to you. Vishesh, is it +3 or -3, Vita? In thermochemistry, it is highly insignificant if you write down, without sign there. Is it +3, -3? See here, for delta solution means you are having 1 mole of this CuSO4 solid and you are having H2O liquid in excess. What for I'm considering H2O because you have to find out hydration. So I'm assuming that it is water as the solvent. Then you'll be having here CuSO4 aqueous. Delta H1 in this case is 25. I'm not writing the unit again here. Now for the solution of CuSO4.5H2O solid, water excess, will you be writing this as CuSO4 aqueous? You'll be getting delta H2 as 28 here. Now, do not think where that 5H2 has gone. You should not write down CuSO4.5H2 aqueous because H2O is there, 5 water molecules, and you are having here excess. So that will get dissolved there, excess of water. Now, basically, what is your target reaction? You want to find out this, which is hydration of CuSO4 solid. So it should basically combine with 5H2OL so that it can form CuSO4.5H2O solid. So this is your target reaction. That is, you have to find out delta H for this reaction, and this is actually hydration of CuSO4 solid, right? So this is your target reaction. Now for target reaction, what do you want? You want CuSO4 on the left hand side. So from first reaction, you'll get it on left hand side. That means deltaH1. Now you want CuSO4.5H2O on the right hand side. And in the given reaction, it is on left hand side. So you'll reverse it. So I'll be writing minus of deltaH2. So you'll be writing 25 minus 28, which is minus 3 kilojoule per mole. Always remember, enthalpy of hydration should be negative. Getting it? And all of you, please read whatever I have taught you in today's class also. Getting it? Do not think only up to Hess law as the syllabus. You have read about, kind of enthalpy of neutralization and the solution. Please revise this also. Getting it? From that portion also you can expect some question. Are we able to get it? So wish you all the best for your test, and I am sharing here the QR code. Please scan that. Scan this, everyone. Hopefully everybody has scanned it, and wish you all a very happy Dashera. Enjoy at your home, right? Enjoy the delicacies of the festival, and at the same time, please do not, totally get disconnected from the studies. Please revise it, right? Yes, thank you, Vita. Same to you, right? Thank you and have a nice day. Negative only. Navya, it is negative only. Whether it is hydration enthalpy for ions or else it is for basically for the compounds, it's negative only.